problem of today is, as shown in on the board, is a functional equation. Okay, it's a functional equation, and we have to know a little bit about functional equation before we can jump to reading books, reading complicated books, reading a much higher level. Okay, we need to know these few concepts. Okay, every class that I will make will have some new concepts in it. Okay, not only techniques, not only some crafts that I can make. No, today we're gonna hear about something new. Okay, and it's the function. Maybe we've learned before in high school, or maybe in the lower education than that, that fx could take the shape of x squared. Yeah, maybe fx can equal to 4x plus 3. Okay, that's what we used to see fx like that, have an exact figure, have an exact number, so we can calculate a certain f when we ask for. So if they ask us to compute f4, it's easy. Just substitute 4, and we have f4 equal to 16. And over here, f4 equal to 16 plus 3, which means 19. Okay, that's what we used to, right? And it could be harder than this, like x equal to 3, right? But even if they ask me to compute 10, f10, how much is f10? Of course, it is 10 exponent 3, which is 1000. See, this is the easy version. Now a new version, we're not used to this version. They don't give us any formula for the f. Only thing we know about f is a relationship, just a relationship. I mean, look, we have f here, f here, f here. But over there, we have an f on the left, and on the right, the formula. But now we have a relationship that connects f to another f to another f. Isn't it right? So, is it harder? Yes, a bit, yeah. But it will get easier. And I wanted to start with this long problem, so our hand will get used to this relationships, okay? But let's read. Function f satisfy for each integer n larger or equal to 1 the following relationship, okay? What does that mean? I mean, I read the sentence, but it does not make full sense, did it? Let's explain. It satisfies this relationship for each integer n larger or equal to 1. Why does they say that? Because they have to. The mathematician needs to interpret the writing in this way. They have to, alright? But you don't have to really stuck on this sentence. It means that you can use only integer in this relationship. Don't use 1.5. You can't use 1.5, okay? Because they are saying only integer. But on the other hand, I'm not going to use any 1.5. I'm not going to use such numbers. Why? Because I'm looking at the problem and seeing 1 and 2 and 3 and 4 and 5 and 6 and 7. Why would I use 1.5? Okay? But anyways, mathematicians need to use this sentence. You feel me? Okay, like this. Okay, so I'm allowed to use an integer as long as it's larger or equal to 1. Okay, let's compute f2. I have f0, f1. Let's compute f2. f2 needs f1 and f0. What do you mean needs f1 and f0? Yes, it needs it. Since we have a relationship between different f's, we need to look inside the f's. We need to focus on what the inside. Don't look at the outside, okay? It could be deceiving, yes? Don't look at the outside, look at what inside f. n plus 1, n minus 1. So a number is connected to the one before it and the one more before, yeah, the more previous one, okay? n plus 1, n n minus 1. So a number is connected to the one before and the one before, okay? So f2 is connected to f1 and f0, and not quite shocking to find the writer of the problem giving you f0 is equal to 1 and f1 equal to 2. Okay, let's use them. Now, if you want to compute f2, you want to use the proper n. What is the proper n? It's 1. You need to use n equal to 1. If you use n equal to 2, you will compute f3. Yeah? And since you chose to put n equal to 1, you have to commit. You need to use n equal to 1 in every position. In every position. Everywhere n must equal to 1. Okay? Don't mix. Okay. Now n equal to 1, f2 equal to 1 multiplied 1 minus 1 is 0. So this is gone. Now minus 1 minus 2 minus 1 is equal to positive 1. So f0 divided on or by 1, 2. f2 is equal to f0 on 2. Yeah, it's a half. Now the next step. Do I stop here? No, I need to compute f3. f3 need f2 and f1. Okay, that's good. f3. To compute f3, I need to use n equal to 2. Yes. And 2 substituted with 2 multiplied by 1 is 2. f2 minus 2 minus 2 is 0. Good, this is gone. Now we have 2 multiplied by 3 is 6. Now we have f2 on 3. We have a half on 3 is 1. See, alright? We have a half is divided by 3. So it's like it was divided by 2 and now I'm dividing it by 3. So it is divided by 6. Or you can say like this. This is the upper hand and this is the denominator. Okay? But now we need to be more professional. I will write 1/6 as quickly as I can since I need to compute f4. Can you tell me f4 is related to which f's? Yeah, f3 and f2. Let's substitute n with 3 exactly. Now everywhere n is a 3. 3 multiplied by 3 minus 1 is 6. f3 minus 1 f2 divided by 3, 4, 12. Okay, 6 multiplied by f3 is 1 minus f2 is half on 12. Half on 12 must equal to 1 on 24. Yes, I'm dividing by 2 and dividing in the same time on 12. That means I'm dividing by 24. Okay, this is easy, yes. Now I need to know f5 as well. f5, let's substitute n with 4. Okay, 4, 3, 12, f4 minus 2, f3 on, okay, 4 by 5, 20, 12, f4, 12 multiplied by 1 on 24 equal to half. Now 2 multiplied by f3 is third. Now 1/2 minus third on 20. Now, I'm sure that you know that a half minus third is 1/6. 1/6 on 120 on 20 equal to 1 on 120. Good. Now we have f2 equal to, I always like to group things. f2 is equal to half, f3 is equal to 6, 1/6, and f4 is 1 on 24 and 1 on 20. Okay, now I need to compute f6 and f7. But, and this is a huge but. I can notice that these numbers have some pattern. What pattern I'm talking about? Yeah, a pattern that I used once, not too much long. The pattern is the factorial. Exactly, the factorial. What do you mean by factorial? Yes, factorial this. 3 factorial is 3 to 1. 4 factorial is 4, 3 to 1. Yes, these are the numbers. 1 on the factorial, 1 on the factorial. So I can detect, I can suspect that the next one will be equal to 1 on 720, and the other one will be 5040. Yes, I multiplied this by 7 and I have 5040. Good? Yes. Now I'm suspecting, I'm not quite sure. How to be sure? Yes, as you can imagine, I have to compute f6. And as soon as I compute f6, I will be surprised that it will be 1 on 720. Of course it will be, because this suspicion is very huge. It's about 90-80%, okay? 98% suspicion that the factorial is really involved in this equation. Isn't that good? Yes, I compute f7 as well, and I will be shocked that it is 1 on 7 factorial. Okay? If you did not suspect that, it's a small problem, not a huge one. It's only huge if they are asking you for f100, if they're asking you for f1000. How can you know it by step? You can't do that. It's a waste of time. You need to suspect if they're asking you for f1000, right? Yes. But in this case, you can simply compute 1 on 7200 and 1 on 5040. Okay? Now, this, what they want in the first place, is very easy to compute. The problem is over. The problem is over, my friend. This huge and complicated functional problem is over. That's it. It only needed patience. Only patience to compute while I'm focused. Is that good, my friends?